Let's start with the TLDR of Mina's protocol architecture. The entire Mina blockchain is represented by a single snark. It keeps the blockchain size constant at around 22 kilobytes. This is achieved by a concept called recursive composition of snarks. Okay, now let's unpack it snark by snark. The problem with other blockchains is that running a full node is resource extensive. It means that anytime a new node joins the network, they have to download the complete blockchain history that has happened before them and then start contributing to the network in the form of validating new transactions. This only increases exponentially with time and limits scalability and decentralization, and hence also security. Okay, so why is it resource extensive? Because of trust. The entire history is required to verify the current consensus state of blockchain, which means that to validate any transaction, the node should be completely in sync with all of the history of the blockchain that has happened till now. This is needed because that's how we establish trust on a decentralized network of anonymous node operators, that the blockchain would be tamper-proof and nobody should be able to forge the records. So then the root cause of the problem becomes the verification mechanism. Let's understand it by a simple analogy. Imagine that every time you went out and spent $1 on a store or on a movie or something that you like, you are checking the entire history of how that dollar has been spent by people before you are going to spend it. I think now you understand the problem. So the next question is, how do we solve this problem? The only way that comes to mind is if there was some way to certify that someone had already checked the history for us, like some sort of certificate. I think it sounds something like that we have already talked about. Enter ZK snarks. ZK snarks, as you might recall, act as a certificate to prove that a computation was performed correctly. These are tiny, easy to check, and versatile, meaning they work for any kind of computation, no matter how complicated it is. Sounds like an idea, right? So how is it used in Mina? In a blockchain, updating a blockchain means changing a state of the accounts of that blockchain. This change in state of accounts is a computation. And snarks can certify any computation. So a snark can certify each block update. But a blockchain is a series of account updates happening over a time. So it should be a chain of snarks then. Yes. But verifying all of the previous block updates, that means all of the previous snarks, is also a computation in itself, which means it can also be represented as a snark. So the entire blockchain can be represented by a single snark. And this is called recursive composition of snarks. One more thing before we move to the next section. The Ouroboros Samasica consensus mechanism. It's a secure proof of stake protocol that is specifically designed to resolve long chain forks without relying on the third parties to provide the previous blockchain history. It uses VRFs, verifiable random functions, to select the winning block producers. It doesn't need any staking minimum, and there's also no slashing.